2,955?
Yeah.
And how many million are we going to do that by?
5.
5 million. All right. Hey folks, welcome this afternoon. TNLearn Mathline. You are watching. I'm Ernie Roberts. I'm your host for this afternoon's specialized segments, all right? Now, specialized segments are a little bit different than our call-in show because you don't call in, all right? But you're welcome to go ahead and send us some messages. You're welcome to send us some questions or problems that you'd like to see on this later show. Go ahead and do that by email or on Facebook. We'll be loving it, all right? But for right now, we're going to ask you to sit back, relax. We're going to work some math problems together on a specialized topic, or as we call it, specialized segment. So, guys, what is our specialized segment topic of the day? The scoop on 45-45 90-degree triangles, sometimes just known as a 45-45 90, all right? So let's see, what are we talking about? That means angle measures, my friends, 45 degrees, and a 90-degree angle. So we are talking about a right angle, and since those other two angles, the acute angles, are congruent, meaning they have the same measure, 45 does equal 45. Yes, it does. Thought I was going to catch you and trip you up there. No, not at all. So that means it's isosceles. So we have an isosceles right triangle. That's what we're dealing with today. And I said something about the scoop on it. Let's take a look and find out what the scoop actually is. Now, if you tuned in last week with us on this show, or last session when you've been watching us, and some of you pick us up online, so whenever you last saw the episode on our other 45-45 90-degree triangles business, we worked it out using Pythagorean theorem. We used the a squared plus b squared equals c squared, because what we figured out, we had this little a right here for a leg, and another a because, as we said, these were isosceles right, all right? So, boy, there's a lot of rights in there, aren't there? All right, right? Good. Oh, anyway, I digress a little bit. And of course, our hypotenuse, we always play with it being c. So the formula for this would have been simply to take a squared plus a squared equals to c squared. And we worked our problems out pretty much using that Pythagorean theorem, hypotenuse-leg relationship. That's where we went, all right? That's where we went. Today, I want to give you a scoop. There's a shorter way to do it, all right? At least with 45-45 90s. Now, this only works with 45-45 90s. As in 30-60 90s, there were formulas. And they were easy to remember because they were like halving and multiplying by a square root of 3 and sometimes doubling, depending on where you started from and where you were going. Well, now let's see what's going to happen when we take a squared plus a squared and get c squared. We're going to see what c actually equals in terms of a formula setup, all right? And soon you go like, oh, you're not going to make numbers yet? Not yet. No, we're going to play with the letters, all right? The variables are going to make things pop on this one. So I've got a 1 and a 1 here. And that's going to give me, guess what? 1 plus 1 is 2. It is 2, right? Yes, it is 2. Yeah, all right, just making sure. And we have 2a squared equaling c squared. Now I'm going to pull it right up over here, bring it up a little higher. And I've got 2a squared equaling c squared. Now the idea is we want c by itself. There's a c squared there. I need a square root. And if I square root the right side, oh yes, I've got to do it to the left. Exactly. So you say, is that a square root property of equality? Well, there should be one. If there is, I don't know. But we do. Basically, the concept of equations, whatever we do to the right, we've got to do it to the left, okay? So we're going to take the square root over here. That gives me c. Pretty easy. Now, what happens over here? I've got an a squared, which is a perfect square. I can get a without a radical on it. Pull the a out and leave the imperfect behind. Now, once again, I took the a out from a squared. That's what the square root of a squared is. And I'm going to be left behind with the radical, or the square root of 2. And my friends, there's the formula right there. Now you say, well, Ernie, what does that mean? Well, that means if you have a, you've got c. So example, if a is 4, then c would be 4 times the square root of 2. That's it. You say, nothing more than that? Absolutely not, okay? Now, there may get a little difficult if a is kind of funky, all right? But we're going to be involving the square root of 2 in all of our problems today, all right? So that's a key thing again. And there's the formula right there. You say, well, how'd you do that? We got it right off the Pythagorean theorem. Remember, a squared plus a squared, and we square rooted both sides. Oh, my goodness, we were home free. Now, that's going to work, once again, caution, works if it's a 45, 45, 90, all right? In other words, we got 45 degrees, and 90 degrees in our triangle. Notice this one's we'll get it right again, no pun intended, there's a right triangle. And here we go. On this side, we're going to do the same thing. But this time, let's say I put in the number 6, and then I also get another leg by 6 because this is isosceles, so the 6's will work, all right? 6 and 6. According to my formula, it's going to be 6 times the square root of 2. 6 times the square root of 2. You say, well, are you sure that works? Of course it is. Of course it does. Of course it does, right? You can do a quick check. Run 6 squared plus 6 squared, and see, does it give us 6 times the square root of 2 squared, all right? So we got a 36. We got another 36. That was easy because 6 times 6. Everybody knows 6 times 6. If you don't, you do now, all right? On this next one, we've got another 6 times 6 because it says square the 6. But we got to square that square root of 2. Boy, that's a lot of squaring, isn't it? Actually, it's just 1 times square. We're going to take the square root and we're going to multiply it times itself. And you know what? That is going to give us, not 36. That came from the 6 part. That's going to give us 2. It's going to give us 2. Because that's what happens. You take the square root of 2 times the square root of 2, you get the square root of 4, which is 2. No root, no radical, no nothing left but the 2, all right? So let's see what this gives us. I see 72 on the left. I see 72 on the right, so I know that works. Formula's going to work for us, all right? Now, what we've got to do is just remember to use it, okay? Rather than going through a squared plus a squared equals c squared every time, this is so much easier, so much easier. Let's see how it works, all right? So, again, we're going to do a little practice on this stuff. And as long as we're multiplying, life is good. Now, if we go in reverse, in other words, if we know the hypotenuse, we're going to have to divide by that square root of 2. That's another story. Hey, hang on. We'll get to both parts of it, all right? Let's take a little bit more practice with going from legs to hypotenuse. See our next problem, see what we got here. Again, right triangle. Oh, that bright yellow, I like that. And it says one leg measures 5. And, yep, that means the other side is going to be 5 also. That was easy. So that's isosceles, okay? So it has to be working that way. Question is, how do we get to the hypotenuse, which we're going to call C? Let's go to our formula. Let's go to that formula. C equals, what is it, a times the square root of 2? You got to trust me on this, all right? By the way, you say, well, Ernie, what's A? A is the 5. A is the 5. They're both A's because isosceles, 2 congruent sides in the triangle. And it's a right triangle. All of these have to work together. Put a 5 in for A. Pretty straightforward. We've got, my goodness, we got 5 times the square root of 2. Now, some of you are going like, well, Ernie, what does that actually mean? What is 5 times the square root of 2? Let's see real quickly what it looks like on the calculator. All right, let's take a look here. We've got 5. Oh, we do have 5. There it is. Times, we'll just pop it right in there. We don't have to put a times symbol. We just simply go for the second and the square root of 2. And we're ready to press enter. That's how quick this is. And it's around, looks like obviously it's bigger than 5. It has to be. Hypotenuse is the longest piece. But if you look there, it's 7 and a little bit extra. All right? About 7/100ths more with a little ramble because it is irrational. Exactly. When you multiply by the square root of 2, you're going to get an irrational value. So we could round it up to 7 7/100ths if we were going to hundredths place. We could go 7 1/10 if we were rounding off to tenths place. All right? So it's all about what you're looking for in that regard. This over here was what we call the radical form, simplified radical form. We're going to hang with that pretty much today. But I just wanted you guys to see what this actually is equal to if you want to get right down to centimeters, feet, inches, whatever units we are using. In this one, we are using inches, all right? So let's take it back to the problem here, guys, and just real quickly. So we will put inches on these. Remember, these are units. These are units just like what we started here. Everything was 5, so all of these are going to be inches all the way across through there. So the 5 inches leads you to 5 times the square root of 2, which we saw was about 7 7/100ths, all right? Close to that when we round off. That's it. How about it? Is it easy to multiply? Of course it is. Easy to multiply by a square root of 2. And if you really want to find out what it's equal to, you can always go to that calculator. Always go to that calculator to figure out the hypotenuse. Let's do a quick run here on this next one. and see if we can just go without even having to think much. We do have a right triangle. It is isosceles, okay? Because it is a 45, 45, and the 90, okay? By the way, if those 45s weren't there, we couldn't call it isosceles. Those have to be the same measurement. And if we're going to have a right triangle here with 90, that leaves us one choice only, 45 and 45. So that's how it all glues together. 45, 45, 90 adds up to 180. We've got a right triangle and the isosceles pieces because of the two congruent acute angles. So you got it? Everybody got all that connected? It's kind of, sometimes it seems like there's a lot, but you know, it all works together. And if you start thinking, oh, one thing fits here, then another thing fits there, you can look at a problem which has maybe bits and pieces of that information, and you can pop right through it. Now, speaking of what we have 8, and we have 8 there, right? It says find the lengths of the other sides. So that leg is so easy. It's just identical, right? And now, new formula. I'll write it up once again. I like for people to, sometimes they jump right into the show, you know, or somewhere in the middle here. So now you see, we're going to use this formula, and this only works, again, because it's isosceles right. We're going to put in 8, by the way, that is our A. So we're going to put in 8, and we're going to see, wow, C equals 8 times the square root of 2. In radical form, you're there. Those of you who like to go to the calculator, be my guest. But we're just going to leave it in radical form for the show today, all right, when we have that need. 8 times the square root of 2, we move on. And by the way, that's usually what they do on the ACT or the SATs. You'll see them in radical form versus the decimal approximation. So that's why we like to play it in this regard, all right? Now, let's take a look at our next problem coming up the alley here. This one says, oh, another right triangle. It is isosceles. Everybody's happy. We have a leg, but the little different this time, isn't there? There's a square root of 2 attached to that 4. And everybody goes, uh-oh, what are we going to do now? Well, I'll tell you one thing you don't want to come up with. You don't want to come up with the answer of 4, because some of you are thinking, oh, we're just going to lose the square root of 2 because we didn't have a square root of 2 the last time on 2 of the pieces. And anyway, no. We're going to go out here, and we're going to use our formula, where C is equal to A times that square root of 2. And we're going to drop 4 roots of 2 right in there, all right? For A, by the way, for A. So C equals 4 times that square root of 2, and we're going to bring one more square root of 2 in there. And I advise you to put that in there until you start getting the really hang of how quickly you can maneuver on this, because that way you remember you've got a root of 2 times a root of 2, and these are square roots, right? So the square root times the square root basically cancels itself out since the same number is under there. It's like saying we have now the square root of 4, which gives us 2. So finally, we have a 4 that is hanging on with nothing going on. And then this little guy here is going to make a 2 for us, all right? When we take the square root of 2 times itself, the square root of 2 times the square root of 2, simply come out with 2. Lose the root, lose the radical. And, oh, by the way, that does give us 8. Those of you who thought it was going to be 4, it can't be 4. That's got to be longer. It's a hypotenuse. So 8 is where it pops out to, all right? And by the way, that is your C value. These are all centimeters, all right? So there you go. Call it 8 centimeters also, all right? And there you have it. Easy, very easy. All we're doing is what? Multiplying by a rational? Nope, an irrational, right? The square root of 2. Why is it irrational? Because it rambles on and on. Not because it's crazy or out of control or something like that, like me at times. No, it is because just doesn't, it rambles on. It does not have an ending to the decimals out there. So it is irrational, and it's nature of the beast. Let's try one more real quickly here, all right? Let's see, we've got another root of 2 hanging out on us, the square root of 2 right there. So here we go, leg time. You say, are you going to get to that hypotenuse? Well, that's where we're going to go, right there. We're going to have to find it. Is feet this time, all right? So this is 5 times the square root of 2, and that's a measure of feet. Remember, that's a minute ago we found that on the calculator. It's about 7 7/100ths to the nearest hundredth anyway. Here we go again, another one, because, hey, they're identical. They're congruent. 2 sides of the isosceles triangle. Now the question is, how are we going to get there? Let's go formula. And I'm hoping that some of you begin to notice that every time you multiply by the square root of 2, and you've got another square root of 2 involved, they basically take care of each other and make a 2 happen. And that's what we're seeing here. So real quickly, we'll write it in there again. 5 times the square root of 2. I'll put a parenthesis around it so we know that's our entry for A. Multiply it by another square root of 2. And remember what I said, those two little guys right there, they go to 2 without a radical, without the square root symbol. Because we're really saying the square root of 4, which equals just simply 2. And the simple answer, we love it, comes out to be 10, and this time it's going to be 10 feet. All right? That's your story. And isn't that nice? Here we started with the square root of 2 on our sides, on our legs. We get to the hypotenuse, it's gone. It's gone. That's kind of one of those things that happened when we did 30, 60, 90s, and the square root of 3 would come and go. All right? But that's based on the fact what we've got in terms of our radical there. All right? So it's going to pop up on the legs, or it's going to pop up with the hypotenuse, but it's not going to pop up in both places. And notice, 10 is bigger than 5 times the square root of 2, because remember, that's about 7.07. And there you go. That means it's definitely, the hypotenuse is definitely longer. All right, so we've been starting with the legs. Let's go to hypotenuse. Let's start with the hypotenuse here and work backwards. Formula is still the same. That is not going to change. You say, well, Ernie, that's about multiplying. You're right, it is. But here's what's going to happen. We're going to put the 7 times the square root of 2 right over there in hypotenuse land. We're going to bring the right angle, because we know that. And we're also going to bring in our congruent side, so we know we need to do that. I'll tell you something. We're going to pop in for the number, or the variable c, it's going to be a number we're putting in there, is 7 times the square root of 2, woohoo, equaling, you got it, a times the square root of 2. In other words, I know c, we'll substitute it in. We're going to figure out what is our a value. By the way, there are 2 of them. They're going to be the same, right? Because a is a. No difference there. So what happens? I want a by itself on this little equation. So we are going to divide both sides by this lovely square root of 2. And what's really great about this, it's just like any number. If you divide a number into itself, it basically cancels out and gives you 1. All right, it doesn't give you 0, but it gives you 1. So say goodbye to the square roots of 2. Goodbye, square roots of 2 on that side. Hey, say goodbye to them on the left also. We are down to 7, and we have an a by itself. Looky. There you go, 7 and 7. And you know what you're thinking, wait a minute, Ernie, that's just like what we did earlier. We started with the 7, we got to 7 roots of 2. Exactly. So that's the whole idea of this formula. You can start with the hypotenuse and work backwards to the legs, or you can start with the legs and go forward to the hypotenuse. And you may think of it in the other way, which one be forwards and backwards and what have you. But they're related. That formula takes care of you on all counts. So, hey, how about it? Let's practice a little bit. How about it? Got it? Let's take a look at our next one. Very quickly ready to rock and roll. In fact, I think it's the same problem again. Well, how good are you? You saw 7 square. Oh, it switched a different direction. Some of you say, well, it looks different. Well, it is. It's kind of looks like it's pointing off to the right here. But we still got 7. This time we're inches, okay? This time we're going to be inches, all right? Now, coming back here, you got it. It's going to be just simply dividing by that square root of 2. That's what we do. And it's going to give us 7 and 7. Hey, that was an easy practice, wasn't it? Everybody got that right? I hope so. Now, let's maybe we'll make it a little more interesting here. How about this next problem? Let's see what we've got going. Whoa! 45, 45, 90. We're good on that. But it's different. Oh, it's not the same figure. Yeah, it is the same figure. It's just turned around. It's rotated a little bit. That's our good word of the day, rotated. So there's the right angle. It's going to go to the top. It's still isosceles, and trust me, you'll see triangles that look like that in that shape. They don't always have to sit on their side or on going facing left or right. This is kind of, well, you know, you can talk about your facing any way you want. This one we are going to look for the legs, but we've got a hypotenuse down here of 20 centimeters, all right? Now, formula. Again, keep harping that formula. There's only one with the 45, 45, 90, and it's c equals a times the square root of 2. This time I'm giving you 20 for the hypotenuse. We are after a, my friends. We're after a. This one's a little bit more twisted, all right? And again, we've got that a times the square root of 2. We need a by itself, and we're going to do just what we did earlier. We're going to divide by that square root of 2, and we're going to divide both sides. Oh, right-hand side, no problem. Those 2's, the square roots of 2's, goodbye, they're down to 1. They just cancel each other out because we're dividing a number by itself. All right, in this case, it happens to be a square root of 2. So A is hanging on, but ooh, we got this ugly looking thing. It's not that ugly. It really isn't. It's kind of nice, actually. But let's see what we would do. Off to the side here, we're going to play a little bit. We're going to say 20 over the square root of 2. That means divided by, all right? And remember, the rule is basically, it's not basically, the rule is rationalize your denominator, all right? In other words, don't have a square root left over there. Now think about it. How do we remove a square root from the square root of 2? Well, we got to multiply it by itself. So we're going to have to square this crazy thing or multiply times the square root of 2. Now notice I've set a little fraction up here because rule is if I multiply denominator by the square root of 2, I got to do it to the numerator. Oh my goodness. Well, let's see what happens. We get out here, I'm about to run out of room for some of our viewers, so I will bring it right down here. 20 times the square root of 2, which is delightful, over, what are we going to have underneath there in that hidden blue? There we go. We got the square root of 2 times the square root of 2, which we've gone through a couple of times in this show. We know it gives us 2 without a radical. That's why we call it rationalizing, because 2 without the square root symbol is rational. It's good. It's wonderful to work with because we can divide 2 into 20. We will get 10 times the square root of 2. That is my A value. That is my A value over here. And some of you are going like, are you sure that's going to work? Well, remember when we had 4 roots of 2 over there for our legs and we wound up with 8? This looks pretty much like the same form here. We could square it back through. We could just put in 10 times the square root of 2 and here you would get 20. All right? So it does check out. It does check out very nicely for us. All right? So let's see another one. How about another one? How about let's put another number on that hypotenuse. Check it out. Here we go. I have a right triangle. This time we are going with 12 for our hypotenuse. We're going to hunt down the lengths of both of these legs. And I want you to start notice something here. Well, we're going to notice it hopefully in just a minute. Question is, what's going to happen with A? By the way, these are in feet, so our answers are going to be all in feet here. Goodness sakes, over that last one was centimeters, and we have inches and stuff. Don't let the units bother you. They're just going to stay the same. They're going to stay the same. They're going to flow. They're going to flow, if you will. Now, where are we going to go from here? We're going to write our formula, as always. We start with that hypotenuse equaling A, which is the leg, times the square root of 2. Again, folks, this only works because it is A, 45, 45, 90. All right, that's why it works. That's why it works. So pop in the 12, and let's see what's going to happen when we divide both sides by, my goodness, there it is, that square root of 2. And nice thing, 12, it goes as even number over there, and that's going to help us a little bit. So off to the side, we go through our little routine. We say 12 divided by the square root of 2. We have to rationalize the denominator. We've got to get rid of that root of 2, make it become a 2. So we're going to multiply by the square root of 2. And we're going to also have to do the numerator by the square root of 2. And you know what? This story's starting to get old, isn't it? Because we got 12 square roots of 2 over 2. And Ernie says, yeah, you can divide this 2 into that 12. Now notice you can't divide this 2 into the square root of 2 because one has a radical, one does not. So we're going to end up with 6 times our square root of 2 here. And I'm going to give you a quick notation on this that'll save us a little bit of time when we have a problem like this. Especially if it's even, it works nicely. And even if it's odd, we'll be able to do one on it. But notice there's a thing called divide and attach. This 12 divided by the square root of 2. And a minute ago we had 20 divided by the square root of 2. And you ended up with well, let's go back over it just a second here. With 20 over square roots of 2, we had 10 roots of 2, or 10 square roots of 2. Here we've gone from 12 divided by a square root of 2 to get to 6 square roots of 2. A little rule I like to call divide and attach. Basically divide this 2 into the 20, it goes 10 times, and attach the radical that you've been trying to get rid of out of the denominator. It'll work. It'll work. Over here, what happened? 12 times the square root of 2 over 2. Divide and attach. My goodness, you will have 6 and bring up the square root of 2 to join up. All right? Now, real quickly, I know we're on tight run here. Let's see one more quick problem here. See if we can do this mentally. We've got 7. You say, Ernie, that's odd. Well, it is odd, but it is an odd number. I don't know if it's an odd problem. But what we're going to do, we're going to do that divide and attach rule, all right? So we're going to go back to C equals A times the root of 2. Put your 7 in there. And we've got what? A roots of 2. Divide by the root of 2. We'll get that right in a minute. How about it? We got 7 divided by the root of 2 equaling A. Divide and attach. You say, what is that going to give me? 7/2 times the square root of 2. And we'll put that square root of 2 on the top. That is what your A is equal to. Wow. All right. So even this odd, you can do it. By the way, that would have been a 3.5 if you wanted a decimal out of it. Hey, thanks for tuning in, Specialized Segments. You know, we're going to be back live next week, and we'll see you then.